and going and starting. And I guess like kind of in relations to what I was just speaking about, BMF with video processing, we're starting to enter a whole new world with how we are creating performant applications on the web. So WebGPU offers a whole new slew of opportunities for web developers. I mentioned video processing. We could talk about using the GPU also to help with large language models. And also what I'm talking about today is creating 3D worlds with Rsbuild as well. So Rsbuild, Rspack, the entire ecosystem can support this. I just used Rsbuild necessarily in this instance. One, for experimentation, and two, also because of all the performance that and the performance capabilities that it brings to when I am building applications on the web that just so happen to be games. So basically, if you know, creating video games is not an easy task. It's very hard to do, and especially trying to build something performant on the web is even harder, right? So this starts to open up a whole new possibility, and we want to be able to explore this and make video games and other tools that are usually you need a really expensive GPU to power, and we can make it more accessible. So let's talk a little bit more about the agenda. We'll talk about the emergence of WebGPU, where it came from, some other use cases, and then we could talk about why the RSPack ecosystem leading into Rsbuilds are a great combination for the future of WebGPU and the future of AAA gaming, possibly. Right. We'll see how this goes. I don't think that we'll necessarily see some huge changes very soon, taking you off of consoles and bring you straight to the browser to run really complex games. However, this is a step in the right direction. And I hope that this talk inspires you to want to start building, contributing to open source projects that I'll mention later on in this talk that are really going to help shape the gaming industry in the future. So again, my name is Joshua Alphonse. I'm a developer advocate at ByteDance's open source program office. So I've been here actually a year yesterday. So it's my year anniversary. So I'm really glad that I've been able to dive into a whole bunch of different technologies in our open source offering. And I get really excited about the things that I can do with RSPack as well. So let's talk a bit about WebGPU. So WebGPU exposes the GPU hardware access to the web for both rendering computations and operations on GPU. So you basically get to unlock a massive amount of performance gains and graphics on your computer. So you can handle machine learning workloads, you can handle GPU programming, and the possibilities are endless. It better reflects how modern GPU hardware works while also laying a foundation for advanced GPU capabilities in the future. So we've seen in the past, there have been a lot of APIs that have kind of taken this GPU approach to the web and to mobile as well, right? So we've seen things like Metal, Vulkan, Direct3D12 by Windows, right? But let's bring some attention to the origins of WebGPU. Where did this come from? And I think we need to understand this before we start to understand why RSPack, Rsbuild, this entire ecosystem is really compatible. So WebGL landed in Chrome in about 2011 or so. So this allowed web applications to take advantage of GPUs, but WebGPL enables an amazing experience on the web. So it created cool things like Google Earth to like interactive music videos and 3D real estate walkthroughs. It was pretty much the web's introduction to 3D world building, right? But now we've taken things a step further from WebGL, which was based on OpenGL that was created in 1992. And we're taking the same approach that WebGL has introduced, but we have changed it to the style of native APIs that makes it easier for developers to access GPU on the web and make more performant and powerful applications and games. So, as I mentioned, WebGL started in 2011. And to keep up with this evolution, as I mentioned, we have Metal, Vulkan, Direct 12. These were a whole new breed of APIs that were developed to efficiently interact with the modern GPU hardware. So these APIs are still supported to this day. They're really powerful. However, the WebGPU has been a successor to WebGL, and has bringing a lot more advancements for a new class of modern APIs. So WebGPU has a lot of different capabilities, and let's talk about some of the use cases that I've seen WebGPU being used and things that I've actually have tested out as well. And we'll go into this a little bit before we talk about video games. So WebGPU, you can see, is being used in the AI space right now. AI is obviously huge, and there's lots of new libraries. There's lots of new large language models coming out. There's so much that's happening, but it almost seems as if the performance and the power of the web is somewhat ignored compared to other ways of handling machine learning models. However, there's been a team at MCAI, who have created a new open source package for WebGPU that takes large language models, open source large language models, and even closed source stuff like from OpenAI as well, to actually bring those models to the web so that you can create experiences like this chat. And it's all powered by web GPUs, no other hardware or anything else that is being used. This is all straight from the web. So, besides just video games, you can still bring AI to the forefront as well. So let's talk about the architecture pretty much of web GPU in a simple form. So there's several layers of abstraction here between the device GPU and the web browser that's running the web GPU API. It's useful to understand these things from the very beginning. So, right, GPUs traditionally are using a physical device, and most devices only have one GPU, but some have more than one, and different GPUs and types are available. So you can have integrated GPUs, discrete GPUs, software GPUs, and so forth. Um, a native GPU API, which is part of the operating system. So let's talk about Metal by Apple, or Direct 3D12 by Microsoft, right? They're programming interfaces that allow native applications to use the GPU, as I mentioned. So the API sends instructions to a GPU and on the driver, and it receives those instructions and it brings it back, right? So it's possible for a system to have multiple native OS APIs and drivers available to communicate with the GPU, which is super powerful. So a browser's web GPU implementation handles communication with the GPU via the API and other logical devices. And there's lots of different benefits, right? The web GPU offers a whole other possibility with shading languages, which we'll talk about in a bit. Video frame processing, it's stateless, and it's really powerful to use. So what the heck does this have to do with building 3D worlds and video games? So WebGPU features has lots of really cool features, but something that you really have to pay attention to are shading languages. And shading languages are programming languages that specialize in programming computer graphics on a GPU unit, right? So the reason why you're able to experience things like ray tracing and shading, and you're seeing all these different lights and colors pop up inside of 3D worlds, is because of shading languages, right? So the classes of algorithms that are like ported to the GPU are due to shading languages. Something like JavaScript can't handle all of the processing that is needed for the GPU. So this allows you to simulate things like simulate physics, how the scene looks, how things are being loaded. And again, like JavaScript will have a little bit of trouble doing this, but you have shading languages that are super compatible with WebGPU, like Wigzil as well, that have lots of documentation And also, this leads into choosing the right tools. So let's just take a quick look at um, just how much a compute shading actually affects, uh, a online experience with 3D models here. So you see, like, we're able to capture a lot of the geometry, the different lights, things are moving here, right? So this is the type of power and processing of these different graphics that a compute shading language can do. And this also, there's a lot of other things that affect how this experience is for a developer, right? And it all leads into choosing the right tools to make sure that your 3D assets are being loaded correctly, that your images have a correct way of being compressed. Maybe you also need to work within a mono repo. You also may need some abilities with module federation, right? When you're working on a huge 3D game or 3D world that needs this type of attention, or even a chat app like WebLLM. So let's go over to why we are choosing some of these right tools. So WebGPU, it presents an exciting opportunity to harness the power of modern graphics. But in tandem, we want to work with some of these emerging technologies that we have from ByteDance, like Rsbuild and Rspack. So I want to focus a little bit on Rsbuild today, which is a build tool that is designed to supercharge the development process because it offers out of the box functionality and semantic build configuration and an array of official plugins that pretty much terrace the path for effortless adoption and immediate productivity gains. Rsbuild's emphasis is on easy configuration and it's really performant oriented. It has a lot to do with performance orientation. It's super lightweight and has a plugin system that allows you to customize, and also you can use plugins that are being created from the community. And you'll see a lot of that power happen with Module Federation as well. Now, Rsbuild can manage WebGPU's modularity, and the benefits it brings to the tables are in terms of the developer experience and the examples that encompass the range that WebGPU offers. So here's a few things. Let's talk about this. Rsbuild itself can help maximize build times, and it's pretty rapid in comparison to other build tools. It's Rust-based, just like Rspack. It comes from the same ecosystem, right? You can get high performance build. Rsbuild integrates with all our other Rust-based tools like SWC, which is vital for web GPU projects, right? Where build speeds are efficient and crucial for iterative testing and complex shader compilation. But you're going to need a builder that's going to be able to handle this to help enhance your developer experience. Rsbuild and Rspack, the entire ecosystem has universal framework support, right? So there really isn't much discrimination between the tools that you already have been using and you having adoption for Rsbuild or Rspack. Rsbuild's framework is Rsbuild and Rspack are framework agnostic, just another way of saying it. And then this all happens in the nature of what it is, and it can integrate with various UI frameworks, and you can adopt WebGPU across diverse tech stacks. That being said, it's really easy to migrate from other bundlers and other systems like Webpack as well. And you can easily migrate, and we have lots of documentation on this. You'll hear a lot more about module federation and so forth later down the line when Zach has his presentation as well, which I'm really looking forward to listen to. Now, Rsbuild and Rspack, but let's just talk about Rsbuild really. It has zero configuration startup, and it has semantic configuration approach and streamlines the setup of projects. Now, let's talk about some of the tools that I'm using to build a 3D world. So I've actually stumbled across some other packages, and I was going on and talking about Rsbuild, but I also do have this other slide here that just explains some of the things that Rsbuild does actually bring to the table. But I mentioned a lot of this stuff already. So I actually stumbled upon a tool as I've been building, like building out different concepts for 3D worlds and building games for the web. I stumbled upon Illusion, which is a game engine that's lightweight and renders 3D models really quickly and efficiently, and it uses everything that has to do with WebGPU standard edition. It features lots. It has lots of features, and let's dive into that as well. So Rsbuild offers like a reliable and ergonomic developer experience, and working together with a tool like Illusion to um, create a 3D world is something that I haven't really seen done with the RS Pack ecosystem just yet. So as the industry has begun to adopt development design principles and composition of inheritance, we'll see that Illusion has taken a different approach with their ECS component system. It has clustered light culling, which is great for when you're doing things with compute shading, physics simulation system, again, compute shading, um, material rendering, dynamic diffuse global illumination, post processing effects. There's so much you can do, and it's really easy to get started. You can literally just install our npm package for Rsbuild, and you can also just install Illusion Core really easy. And the documentation, honestly, for Illusion is really great to get going. That team is doing some good things. So let's talk about the core of Illusion, which is kind of similar to a lot of other game engines. And I'll have some honorable mentions later down the line. At the core, Illusion is inspired, again, like I mentioned, by ECS structure. So it follows the principles of composition over inheritance, and the implementation of the component system is like we can see there's a divide in the traditional complex logic into like these reusable components and parts. And Illusion has just taken a different approach when it comes to that. So let's take a look at this entity container that's here, and the entity container is for components that connect to various components, and it doesn't have to have actual functions. Will not render or express the functions. In practice, here, what I'll show you in code is that this is able to create our 3D objects and our scene in our 3D world application. So if we go here to our code, and you should be able to see my screen now. Yeah. If you go here to their code, we also have this is us setting our stage in our 3D world here. We'll just start with our class for our sample skeleton. We're also using our illusion, and we create our 3D engine, and then we just create our scene with the world, and we add different components to it, similar to what I showed you with what the entity is doing. So now our entity is our 3D scene, and we're adding more components. We're adding our atmosphere, which is the actual skyline and the sun that's in the sky that you could see. If I scroll over here, let me just zoom out a bit. Oh, wait, I didn't add the sun here. But yeah, so the whole atmosphere is basically everything you see in the background. We have our sky, and we also have our camera, which is another component as well. So our 3D object is a built-in entity in the engine, and it usually is based on the component container. Again, so this is pretty much what happens when you have our 3D object that we have right here, right? We have our ways to transform the object. We can change the position, rotate and scale it. We can change the point and light, how the light and the shadows in this 3D world actually look more realistic. We have our mesh rendering, which helps us control our geometry and how the materials are being rendered. And again, you're going to need a powerful build tool or a bundler as well to help process all of this type of data and all these types of 3D models as well. We have our scene 3D, which I mentioned before, which is at the core again, which sits at the top here and is inherited by our object 3D as well, which has the same properties and methods. The difference is that the scene 3D here is the root node of the engine rendering, and it's the highest level of the scene tree, which all nodes need to be rendered and must be added to the scene in order to appear. So everything else here are just its child nodes. So again, I've set the scene and I'm adding all these different components here in order to do this. The reason why I'm showing you Aura Illusion is because one, it's open source. It's really compatible with RSpack. And again, it's really ergonomic and easy to use, just like how RSpack and Rsbuild are. So we have our components again, which are our modules or our data, like our 3D, models, and so forth. And this is where we define our logic and callbacks and lifecycle, and we can freely combine these components and entities to have different functions. For example, our camera position. The same reason why I'm able to change the camera position here is really just due to the components that I've added here for the aspect of the camera using a hover camera. So if you wanted to create a first person game, you can just change this to a fly camera. And again, this npm package, this entire system that Aura Illusion has created for their game engine is super powerful. So here's just another list here of all these other components that you could work with, from your camera. You can transform different models that you create. Let's say you create a model in Blender and so forth. You can transform them. You can change the spotlight. Basically, everything here are the tools that are used to create these 3D worlds. So why would I use RSpack for any of this, right? Let's talk a little bit more about it in some more depth here. So one thing that I really love is the fact that Rsbuild and Rspack offer a plugin ecosystem, again, that allows extensibility. With plugins, developers can extend the core functionality of Rsbuild and or Illusion or any other game engine, for that matter, for the web, and enable tasks such as minification. Um, um, and you can also view advanced analytics on your 3D rendering as well. You have integrations with different plugins so if you create your own customized plugin, you can go and integrate third-party solutions as well. You can support module federation. You have smooth migration tools if you are already using another system. And Rsbuild is a really built Rsbuild, you can see performance gains and speeds by over 10x as well in some cases. So some of the things that I want to see moving forward are some more first-person and 3D games in Rsbuild and Rspack. I do have a blog post that will be coming out soon with a tutorial on how to build these games. I know I don't have enough time to necessarily give you a step-by-step code tutorial, but I want to open your mind to thinking that these types of creations are possible on the web. WebGPU has only been around since 2022, and there's so much more that this team is working on to help revolutionize how we are creating 3D worlds and gaming and so forth, right? So I hope that this has allowed you to, open your eyes and see what's been going on in the industry. And everything is open source. So there's possible future here. Players can use any machine pretty much as long as it has a supported browser. So for the most part, WebGPU is really supported on Chrome. So if you have Windows, Mac, Chrome OS, you can use WebGPU game engines on pretty much any device that has Chrome. It's less resource intensive and it's more ergonomic. We don't have to worry about using languages like C++ in order to build really good games or really good looking games. Although C++ does have a lot of positives, sometimes people don't have the same time and dedication to spend on learning C++ when they've been working with TypeScript for a majority of their career. But this gives you the opportunity to do that. So some honorable mentions before I go. We have Babylon.js, Dawn by Google, and then here's some other how the ecosystem has extended. We have Play Canvas, 3JS, Unity. You can also see WebGPU used in TensorFlow.js. So I can only imagine what you can build with RSpack, Rsbuild, WebGPU, TensorFlow.js, and some more tools moving forward. that's it from me. So if you have any questions, I'd be glad to take any questions that we have in the chat. And thank you.